So why am I kind of qualified to give this talk? Well, I have to be totally honest. I've got a little bit of imposter syndrome standing up here just because I wish by this point in my career I had made a lot more geothermal heat projects happen than I actually have. But with the help of my colleagues at TownRock and a few other dedicated clients and partners, we have made a couple of projects happen. I'll talk about a small selection of them today. And I'll talk about my current thoughts on some of the most important aspects with regards to making a project happen, because I guess that's why we're all here at the end of the day, doing our research, facilitating discussion in the political sphere, talking to heat customers and innovating new technologies. It's because at the end of the day, we want to build projects that reduce carbon emissions. And we're not building very many of them, at least in the UK and Ireland. So let's try and build more, and I'd like to help in whatever way I can. So just first, a little bit about TownRock. We are just over a decade old. I set the company up in Aberdeen, which many of you probably know is the center of the UK's North Sea oil industry, and so there's a lot of really high caliber subsurface expertise there, and it was a great place to start the company to bring some of those expertise into the company in the form of our other directors and also some of our suppliers. The company is now based in Edinburgh because I honestly think it's a much nicer city to live in, and I have the choice. But we still work with some companies that are based in Aberdeen, and our mission has always been to use the abundant geothermal heat of the UK geology and globally to help reach net zero, to prevent catastrophic climate change. And I think that's become quite nuanced, because if the target is to reduce carbon emissions, then there's really a lot of variables that have to be understood to get to that focus point, commercially and also socially and environmentally. So it's been a real passion project of mine, and I'm very grateful to say that we now have a team of about 12. This photo is not everybody currently, so it's taken almost a year ago at a conference we were at, but we're about 12 people and still growing, and really the team share my passion. So it's a really gratifying place to be right now, given the first half a decade was a pretty lonely space. So there's three main project types that we have expertise in and experience in. There's actually 5 project types shown on this diagram. On the far left, you've got ground source heat pumps, and then going a little deeper, mine water heat pumps where flooded coal mines exist. A little bit deeper still, you've got the sedimentary aquifers that could be analogs with oil and gas reservoirs, just with no hydrocarbons in. And then you've actually got the oil wells that could be repurposed. And then the deepest end, you've got, some people call it hot dry rock, some people call it EGS, some people just call it fractured granite resources. We then categorize those a little bit more broadly. So we've got a deep geothermal department, we've got a mine water energy department, and then we've got a thermal storage / ground source heat pump department, which also looks at borehole thermal energy storage and aquifer thermal energy storage. So I'll talk about, I'm gonna give you an example from our case studies of one from each of these projects, but we have worked on many more. It's also worth noting just that the word heat in my title is really important. And if we're looking at this really deep hot dry rock kind of granite resource, this type of resource is well suited in some cases to consider for power production or also for lithium production. And so, but I'm talking today about heat as I think heat is the most important thing for us to be focusing on, specifically because 50% of our energy usage roughly is for heating, whereas only 30% is transport and 20% is electrical power requirement. So we have a huge opportunity to displace fossil fuels by replacing gas burners or other types of fossil heat generation with geothermal heat generation. Before I jump into the case studies, I just, in the topic of making things happen, and in the topic of perhaps storytelling, this might not be a particularly sexy story to tell, but I'm on this slide is the journey that we want to take our projects on. And our project is usually a group of people and a place. And we need a vision for that allows everyone to understand where we are in the journey and where we're headed. And this is about as simple as we've been able to break it down to. So some of you from the construction industry or the oil and gas industry will have seen diagrams like this that perhaps have more phases, perhaps pre-feasibility and feasibility and detailed design, etc. This is what we've done to try to keep it really simple. So our discover phase is where we carry out all of the desk-based work that we would need to do to understand the technical and economic feasibility of a project. The prove phase is where we actually start collecting new data, and that's usually in the form of either non-intrusive or intrusive surveys. And so in some cases, there would be justification to do geophysical surveys. In almost all cases, there is a requirement to do a test drilling program of some sort. And the collection of that data is followed by the biggest decision gate as to whether there's how big is the geothermal resource, and therefore how much investment can be justified to put into it to generate energy. It's worth noting each of these phases is concluded with a decision gate as to whether the project is worth proceeding or not. And the hardest decision gate that we've found to get through is actually after the discover phase into the prove phase, because there's a significant jump in spend required, and we'll talk about that a bit on the next 2 slides. But after the prove phase is when you're then looking to spend the most quantity of money. And so the prove phase has to be defined very, very carefully to ensure that the outputs allow your team to make the decision to progress to full-on investment or not. And once you've delivered the project, essentially there's just a decision gate on how the system needs to be operated to suit the needs of the customer, whether that's a heat network, whether that's an industrial user, or whether that's just a building. We currently have projects at all phases of this timeline. And to give you a little flavor, we've had about 50 go through some or all of the discover phase. We've carried out 6 exploration drilling programs. We've delivered 2 projects, and we currently operate 3 projects. And it is obviously possible to jump in and out of these different phases depending if, you know, a heat customer or project developer or a contractor needs you to come in somewhere on this journey to help take the project forward. Here's an example of a little more detail across that timeline. And again, just in the interest of showing a vision of to where we might be going and how long it might take. This is quite a realistic timeline from a deeper geothermal project. The HSA there stands for hot sedimentary aquifer. So that would be your most kind of common type of geothermal resource that would be considered for heating. Would often require a heat pump, but could sometimes operate without the use of a heat pump if the source temperature is high enough to meet the demand requirements. And this is a 4-year development program whereby we assume no faffing about in permitting or in fundraising. And so that's just an indication of the kind of timeline you need to be thinking about, both being able to fund your own time to work on this project, but also to keep the momentum going with the rest of the team and all the other suppliers that are coming in. And of course, keeping the funders excited and interested about the project. This is, again, an HSA project specifically based in England. So you'll see reference to the EA, the NSTA, the HSE, etc. This diagram I borrowed from the geothermal power industry just to show you this cliff edge here. Geothermal heat projects don't have quite a dramatic cliff edge as geothermal power projects. and they actually have a bit of a steeper cost curve at that cliff edge as well. But I haven't made one for a geothermal heat project because I actually think that every project has quite a lot of nuance attached to it. And so we'll do this on a project basis. And I'm afraid I'm not going to share any for any specific project due to confidentiality reasons. But this general trend shows you the cliff edge faced by projects at that test drilling phase, when they have to spend quite a bump in capital, and the risk is extremely high before that spend. And that's where we find a lot of projects stuck unless they get a very forgiving source of funding. And actually, I don't know of a single geothermal project in the UK or Ireland, aside from some shallow closed loop ground source heat pump projects, that has happened without this phase being supported with some or a lot of grant funding. And that's kind of where we are right now, that grant funding is required to get past that hurdle, and is actually sometimes required to also to meet a funding gap in the capital cost of the construction phase, so that the investors can still make a sustainable return on investment. So to jump into some case studies, just a little flavor of some of the work we've done in deep geothermal. We have been looking most recently at using a sedimentary aquifer in England to heat a hospital, but we've previously looked at using a deep fractured granite to power a cluster of distilleries. And we've also helped the North Sea Transition Authority understand some of the risks and benefits of repurposing onshore oil and gas wells to become geothermal wells, and how they should be considering it from a kind of regulator's perspective. Many of the deep geothermal projects that we've worked on have got stuck at the end of a feasibility study. And we, as a result of that, have decided to focus a bit more of our time and energy on making shallower projects happen. But that's not to be said that we're not keen to see these projects happen. It's just that if we're focusing on pushing forward with our own pitch, if you wish, we're focusing more on the up to a few kilometers depth into a sedimentary basin, or shallower than that. But this gives you a flavor of one sort of concept that we've been looking at in a sedimentary aquifer play. In this particular location, we had 3 possible permeable aquifer targets with quite a plethora of oil and gas well data to analyze before making a proposal for the concept design. This would be a kind of single well pad 3 doublet setup, which is targeting the shallowest resource, but could certainly be specified to target either of the other 2 resources as well. We modeled all 3 of them. The way that this then allows for scaling up of a deep geothermal or medium depth geothermal heat source from a familiar sedimentary type rock means that you don't require to have a large heat network built from the outset. And for many of you who have worked on geothermal or worked in the heat network space, you'll know that building and expanding a heat network is a very, very complex and time and capital intensive exercise. So if you have a way of scaling up a geothermal system alongside the scaling up of a heat network, then you can actually have a more realistic multi-funding sort of staged approach to the project. One question I want to throw out there, in case we've got any drillers or exploration geologists or kind of reservoir engineers who want to take a bat at this, but one problem we see with this concept is if you don't actually have a very nearby well, and you're not sure how much secondary permeability you're going to get from the mostly vertical fractures as these wells reach horizontal and cross-cut a lot of those fractures in the permeable aquifer, how does one try to accurately assess which of these 3 units may be most productive with a vertical exploration well? Or is that simply going to never give you a realistic output? I'm all ears. So moving on to mine water geothermal, the area of Scotland that is underlain by mines is shown on this map here. And this type of project we have developed and we are operating. And the reason why mine water perhaps has had a little bit more traction and a little bit more attention to date than deeper geothermal projects across the UK has been because of this really clear overlap between areas of social deprivation, energy poverty, and the presence of coal mines, because of the direct linkage between the closing of those mines and that social deprivation. So those areas, and especially the northeast of England, where we've had the most attention, is where there's a big opportunity to provide a large proportion of the heat demand of those urban areas with the heat from the flooded coal mines. I'll talk about the operational projects in a second, but just to mention that whilst these projects have been built and operating, and there's about, I think, currently 18 operating mine water heat projects around the world. So it's pretty tiny on the grand scheme of things, but there's lots of innovation gone in to make those projects work and stack up. And there's a lot of learning that's been published. There's a great academic community around this type of resource. And so there's continued R&D to make this sort of most fit for purpose for the way that infrastructure and heating systems are funded. One of those things that we're looking at is through this research project called the Edinburgh Geo Battery. And this is looking at taking waste heat from a very large supercomputer, a data center owned by Edinburgh University, and looking at the feasibility of dumping that heat into the flooded coal mines just outside Edinburgh, and then using the mines either as a thermal store or even as a subsurface heat network, and allowing for that heat to then be used by customers downstream of the groundwater flow. So it's a well-funded project. We've got partners from the US and also from Ireland, from Dublin. And we're about halfway through this project, and there's some starting to be some really interesting insights have come out of this. And we're now working on some of the techno-economic and commercial elements, which will hopefully then start to grab the attention of the wider industry, including the heat network sector. But it's important to say we're partnering with Midlothian Energy here, that includes Vattenfall, who are a major heat network developer in the UK and of course in mainland Europe. We're very interested to understand, where do mines and geothermal energy fit into their service offering with regards to long-term low carbon heat supply and heat network operation. So here's a little cross-section showing you the concept there. We've got a data center on the left. We're dumping heat into the mine. The heat flows downstream. And then there's another abstraction and injection doublet that feeds a heat network clustered by an area of demand. Now, we're using some pretty conceptual models here just so that we can start working up different commercial scenarios and run the cash flow modeling and other economic modeling to see, how do people make money from this, which bits of it need to be owned by someone with subsurface knowledge, and who are the key interactions between these different kind of commercial entities. But in operation, the first two multi-megawatt schemes happened in Gateshead in the northeast of England, because this company, Lanchester Wines, just decided that they would try and make them happen. And it's a bit of an unusual story. And it's one where I think that this has pushed the envelope of the mine water industry more than any research or policy ever could, because there was a relatively medium-sized company that just built two projects out of nowhere, and were then able to be pointed at as case studies. Now, how these projects happened, and we came into the journey about halfway through, as I kind of mentioned earlier, was their brand is to be the most green wine distributor in the UK. And so their entire marketing strategy revolves around them being carbon negative in their activities. So if you're buying wine from Lanchester Wines, then you are helping them to reduce carbon. And that's because they have invested in renewable energy across their entire asset base with wind, with lots of solar PV, with lots of efficiency measures, and the first 2 multi-megawatt mine water heat pump projects. But when they originally contracted a company to build these projects, this hadn't been done before in the UK, and there were some hiccups along the way. There was also a very challenging regulatory process, which caused quite a lot of delay and quite a lot of undue stress and uncertainty around the projects. But I'm really pleased to say that they're actually running very successfully now, and we've been able to help them quite a lot in the last 2.5 years to take them from operating from a functional perspective to operating in a really optimized sense. Total installed capacity is 3.6 megawatts, and off the back of them being quite philanthropic with their data, they shared a lot of data with the Coal Authority and with Gateshead Council. Gateshead Council has managed to build a 6 megawatt scheme in the same mining block very nearby. And now all 3 systems are operating next to each other. And we've got I can't show you right now, but hopefully a future talk will show you the operational data that now show these 3 multi-megawatt mine water heat pump systems operating, and you can see in each other's operational data the other ones operating and how they interact hydraulically, and we can kind of balance them against each other. And it's again paving the way for how much mine water heat could be provided from any local area, given the structure and connectivity of the different mine workings, and how long can that be providing the same amount of heat for? Do we see reductions in temperature? There's going to be a lot of research that goes on here, and it's great to have these operational sites to research. So body heat, you saw the video at the start, and we made some nice little graphics. The system launched at COP26 in Glasgow, so it had quite a nice little taste of PR right at the beginning before we even built it. But the system is a borehole thermal energy storage system that's paired with a venue that has lots of events where people will come and listen to live music and live gigs and do a lot of dancing and generate a lot of body heat. And it captures that heat and stores it in 12 200-meter deep boreholes. And then that heat can be recovered from those boreholes when the building needs heating. There's also a second building attached to it, which is an art and graffiti studio. And the foyer of the building is also connected to it. And we do have the ability just to move heat between the rooms, but often it's moved into the ground because it's often either quite cooling dominated or quite heating dominated. Again, we've got 1.5 years now of operational data from that system, and that will be going out as another suite of kind of publicity, probably in the summer when we get close to the 2-year mark of operation. This is a little schematic of how it works. And if you go to this website, bodyheat.club, there's a website narrated by Begbie from Trainspotting. And these are just clips from the animation that shows roughly how the system's working. The reason we went for a closed loop borehole thermal energy storage is because beneath the site there are coal measures and there aren't any coal mines there. So it was pretty poor permeability, shales, mudstones, a little bit of thin coal bands, and some sandstones. And so the only real geothermal technology worth installing there was closed loop boreholes. What next for body heat? Well, I actually was on the call with a major festival in Belgium this morning who would like somehow to implement body heat conceptually into a 12,000 person festival tent for a 5-day festival. So we're gonna have to think outside the box of how we can do the body heat without actually any geothermal at all, and perhaps just with direct waste heat capture and heating of water or otherwise. But gyms, leisure centers, and permanent venues are all places that we're exploring. And we're looking at how we could help some of these venues that perhaps don't have a lot of capital to invest. And we could help them by partially funding some of the capital required to build these systems. But I think most importantly, we have this system is a communication opportunity to get people excited about being involved in a net zero heat project. When you talk about renewable heat or geothermal and net zero heat, and a lot of people kind of switch off because they don't really know how it could ever be a part of their lives or affect them as individuals. And this is one way that it really can. So just to kind of wrap up before we go into Q&A, I've got a few points here on what I thought needs to happen to make a project happen. I think we have a lot of great research and a lot of good people improving the technology, but I don't think that those things alone are what make projects happen. I actually think more importantly, there's 4 levers. And the first one here is the brand enhancement opportunity that building a geothermal project has. That many large energy consumers have net zero targets, and they will do whatever they can to appear as if they are actually decarbonizing without actually putting much investment in. And I think they will be coming around to the fact that it's not an option to just greenwash their way out of climate change and out of action. And so the more that this is used, that the positive marketing, the positive brand enhancement is leveraged to get people within those organizations to take geothermal seriously, the more likely I think projects are going to happen. And that leads me to the second piece here, which is on project champions. And every project we've seen happen and been involved in has had at least one project champion within the organization that is using the heat and owning the geothermal system. And so as much as one would like to think you can have a lot of control over this if you just understand all the benefits, we as a company and as a consultancy don't have that power. We can give them the tools, but it has to come from them to actually champion and make happen all of the moving parts inside their organization that actually will bring the capital in to build the project. And it takes multiple years of hard work and staying really focused for that person to maintain that internal organization. The other mine water project in Gateshead, run by the local authority, is run by a guy called Jim Gillen, who has just been an absolute champion for Gateshead Council's heat network for many, many years. And it's built a really state-of-the-art heat network. But equally in Lanchester Wines, Adam Black was just committed to making these projects happen against all odds. And in Body Heat, our client who owned the venue was committed to doing this as part of his net zero strategy, that he wants to achieve net zero across their whole venue and supply chain by 2025, way before any government targets are set. Education is a massive one, and I think this is where webinars like this are fantastic, for connecting people and for disseminating knowledge and ideas, because we found that, and it's not time you can really easily charge for as a consultant. You charge for technical designs, and you charge for modeling, and you charge for writing up of reports and presentations, but you can't charge necessarily for all the time it takes to start from scratch and explain how this all works and how it all fits together. So that, from our experience, means you need to spend quite a lot of time doing that. It takes probably twice as long to get through the regulatory kind of permitting landscape because of that, because even the people in the regulatory bodies need, in our experience, to have a lot of educating given to them. And finally, collaboration, because none of the projects that we've made happen have happened by ourselves in isolation. It's been through partnership with our clients and, of course, other companies in the supply chain and local political will. One little example I put here is the value of perhaps collaborating when you're considering drilling deeper wells. And so, depending on the depth of a project, you might have between 30 and 60% of your capital expenditure on the subsurface elements, on the drilling and completion of the wells and the boreholes. And if you were to look at the really high risk exploration phase of that, and then you were to actually aggregate a number of deep drilling projects together, then the cost can be brought down and the value can be brought up. And that could be, for example, in a basin where there's a number of projects looking to all drill in their own areas for an exploration program to understand, well, what's the realistic flow rate and temperature that we can get to heat the city. Then, despite the fact there might be different operators considering those different projects, the value and the cost reduction in tendering out those boreholes together and then pooling the data and allowing people to analyze it together is probably the only thing that will allow us to accelerate this sector quickly in the UK and Ireland and actually make projects learn from each other and work cost effectively. So I'm a big advocate of collaborating. So to end, I put some supposedly binaries, 3 binaries on this slide. And I just want to say, I do think we need to be trying out all technologies and we need to be funding all possible options and routes to net zero. But I do have opinions about which ones are probably more valid than others in the area of geothermal. So in the debate of closed loop versus open loop, and why the closed loop guy is basically saying, well, you don't have to worry about geology anymore, so just trust us. We don't need to worry about geology. If you've been watching the race it's in the US, Fervo, and in Canada, Everloop, they're the 2 geothermal technology companies that are really worth watching in this debate. So Fervo are an EGS company who are planning to create their own synthetic sort of EGS reservoirs. Everloop are building massively complex, deep, closed loop heat exchangers through networks of deep wells. And Everloop are claiming entirely conduction-based heating, whereas Fervo are very much creating permeability where there isn't any to get more surface area from the rock. Both will probably IPO. Who's raising money faster? They both raised about 300 million from my count. I think Fervo's slightly ahead. My money would be on Fervo. That's because I'm an open loop guy and I prefer the idea of creating a reservoir than trying to rely on conduction. But from our models, if your heat does just come just from conduction, a shallow ground source heat pump is always going to give you cheaper heat than drilling a deep geothermal single well. That's just the reality of the models. And if anyone can show me an evidence otherwise, then fair enough. And if you have already drilled a well, a failed geothermal well, or an oil and gas well that needs to be decommissioned, then that's fair game. That is definitely something that should be repurposed or considered to be repurposed into a geothermal heat source. But if you're starting from scratch and you've got to drill, it's going to be the less than 200 meter deep closed loop boreholes that win on a conduction basis every single time, just because it's much, much cheaper to drill in those shallower depths and you can get the same surface area. Shallow versus deep. Well, leading on from that, why would we drill deeper? Well, because we need to get higher temperature heat. Is it only worth where is that worthwhile? Well, really, when you've also got a very significant flow rate at depth, because unless you're Fervo and you're doing a massive amount of stimulation to create that flow, to create that permeability, then you need to know that it's there. And drilling deeper and deeper into an unknown geology is extremely high risk and probably not worth risking the capital on. Or if you're in the middle of New York City or the middle of London and you're going to do a conduction-based system, but you've only got a very small area of land to drill on and you want to get as much heat as possible, then you may go against the economics simply because of space constraints and drill a deeper closed loop system. But really, how much capital are you willing to risk on one deep well when drilling is sort of carries quite a lot of risk, and obviously with the right qualified team can be done with very acceptable levels of risk. But if you drill lots of shallow wells, you're more like you can afford to lose a couple due to technical issues. Whereas if you put all your money in one deep well, you really can't afford for anything to go wrong. And then interestingly, in France, which is a geothermal air market that we point out a lot and say, look, a huge proportion of Paris, I think 20% of Paris is heated from deep geothermal doublets producing from the sedimentary aquifer, and the electricity is nuclear and therefore relatively stable pricing. Why are ground source heat pumps being built at a rate 10 times less than air source heat pumps? And air source heat pumps are selling at 10 times greater rates. And really those stats are from the domestic space, but really we're just talking about people who are making decisions on buying things, and that's similar in large organizations. If the electrical OpEx is not a driver of consumer behavior, it's just the installation CapEx, then we need to be really aware that we need to bring that cost and that risk down of the capital installation as much as we can, despite the fact we have a big OpEx improvement when using the ground. And finally, in geothermal, it's often thought about that we are producing heat from the ground, and in many cases, historically, that is exactly what a geothermal system is designed to do. But that won't work long term. I'm talking about like the rest of this century, because the heat will be depleted at the rate at which most projects are producing it. And actually, there's a whole piece here whereby we're missing an opportunity. If we're developing a smart energy system and we see already, even from a consumer perspective, we can be part of that smart electrical grid, whereby there's opportunities to save money or to even be paid to reduce your electrical consumption and do demand-side response services for the electrical grid when needed. When you have a large aggregated power capacity requirement across a bunch of heat pumps, whether they're ground source or water source or air source, and they can charge up portions of the ground with heat when electricity is free or very, very cheap, then that heat can be recovered when heat is very expensive. This could be the most meaningful source of revenue for a big heat pump based heat network. And so let's stop thinking about geothermal as an extractive industry, and let's start thinking about it as a really key thermal store in that smart integrated energy system that we're building for the future. So thank you so much for listening. I hope that was interesting.